Bonjour, welcome to Wahsa Distance Education Center's radio Zoom classes. This is MBF3C, grade 11 college math, and I am Bronwyn Slate. If you'd like to participate live, you are welcome to call the Wahsa studio and you can ask me questions. The number is 1-800-465-7144 or 737-4017. You can listen on the radio at 91.9 FM or on television at Bell Express View channel 972. And you're always welcome to join me live through the Zoom link, which is available from me, your teacher, and also your DEC. Our class is scheduled Monday through Thursday from 11 till 12 in the morning, and we are now in week 6 of our 9-week course. At this point, you should be submitting some work. So what work to submit for marking? The questions marked with the pencil icon are the support questions, and they are not for marking. They're just practice. So you decide which ones to do and how many to do. If you're understanding a concept, feel free to skip. If you need more practice, that's fine. And just let me know and I can send you some more practice. There are answers in the back of your booklets. So check your work to make sure you're on the right track. However, mistakes have been found. So if anything isn't lining up, let me know and we can check that out and see if there's an error in the booklet. The key questions, the ones marked with the key icon, are the ones to submit for marking. So please do all of those questions, show all of your work, your steps, and your thinking. I can only give you credit for what you show me on your paper. So please give it all to me so that I can give you credit for all your understanding. To submit your work for marking, so there's 3 methods. The first method is to scan and send your work in electronically. You can scan in your completed work through a smartphone if you have one. There's the iPhone's Note app has a scan function, and the Android Google Drive app has a scan function. If you don't have a smartphone, you can just send me a picture or scan using a printer scanner is fine too. Then send it to me either through email to studentwork@nnec.on.ca and CC it to me, bronwyn.slate@nnec.on.ca, or you can send it to me through Facebook Messenger, where I'm found at bslateWahsa. The second method is to drop off the work in Sioux Lookout. We have an outdoor mailbox at 74 Front Street, which is the big red building next to the post office on the main street. We have a small white mailbox next to our side entrance, so you can just stick it in there. It may take me a couple of days to get it because we're still working remotely, but I'll get it back to you as soon as I can. The third method is to hand it into your DEC. Then your DEC can either send your work through the Express or fax it to 807-737-1732, or through the toll-free fax to 1-800-463-7852. If you have any questions or concerns, please contact me. This is what I'm here for. My email address is bronwyn.slate, which is spelled BRONWYN.SLATE@nnec.on.ca. You can connect with me through Facebook at bslateWahsa. You can call the main office and leave a message for me there and I can return your call. The number is 807-737-1488, or you can call toll free at 1-800-667-3703. My office hours currently are Monday through Friday, 8 a.m. to 2 p.m. and I'll get back to you as soon as I can. If you'd like to connect with me through social media, my Facebook and my YouTube channel are both under the names bslateWahsa. You can friend me on Facebook, subscribe to my YouTube channel, and all of our radio Zoom classes are uploaded shortly after airing on YouTube, and then I share them on Facebook. So it's an easy way to access our lessons. There's also short videos explaining common errors and confusing concepts on my YouTube channel. So it's a great place to look if you're struggling with something. It might be a previous concept that you didn't really get before and you need some refresher, or maybe something part of our course that you just need a little bit more attention. There's a couple of videos that that help with a few of our concepts that are just more specific to that. So it's like a 10-minute video that really focuses on one concept. So that's a great place to check if you're struggling with some of our work. Math is a really visual subject. So accessing the videos is going to set you up for the most success. Then you can see what I'm doing. It's really difficult to hear only what I am saying and understand exactly what that means, because math is about spatial awareness, about laying things out, organizing your information. So just hearing it is definitely challenging. So you can, of course, join me live on the Zoom, or you can watch the replays on YouTube. If you don't have access to consistent, reliable internet, but would like a copy of the videos, you can let me know and I can send you a USB key or something in order to get you the videos, but you don't need to use the internet then. All right, we're on day 20 of our course, and we are diving into lesson 13, which is the cosine law. Last week, we talked about primary trigonometry, which was just sine, cosine, and tangent. And then we talked about the sine law. So now we're looking at the cosine law. So our learning goals are that at the end of this lesson, you can say, I'll be able to interpret information and then draw and label diagrams, and I will understand how to use the cosine law to find unknown sides and angles. The success criteria is that you can explain when to use the cosine law, and you can solve for unknown sides and angles using the cosine law. All right, so first we're going to activate our brain and do a little bit of mental math. We know that I'm not a fan of the Mad Minute math fact tests that many of us experienced in elementary school. They were drill and kill. They didn't teach us any skills. They didn't teach us transferable skills that we could use in our lives. They were just stressful. So that's not what I encourage. We work through different strategies that help us get more familiar and comfortable with numbers that we can use in various situations. We actually have tools that help us opposed to just stresses and having to rely on our memory. All right, today our question is 74 take away 36. And there's various ways you could do this, but we're going to look at the idea of adding up, which many folks actually do. It wasn't a strategy that I was ever taught. And so when other people in my life showed me it when I was older, I was like, oh, that totally makes sense. People do this often with money, where you're adding up. You're starting from what you're taking away, and then you're adding up to how much you have, and then you're finding the difference, and that's what the difference is. So for this, I like to visualize it on a number line. You do not have to, but I like to do that. That helps me organize my information. So if I'm starting at, again, my question is 74 take away 36. So I'm starting at 36 and I'm trying to get to 74. I'm trying to figure out how much it takes for me to get there. So from 36, I'm going to jump to a friendly number. So I'm going to jump to 40 by adding 4. That's a friendly number for me. Then I can say, okay, I want to go from 40 to 74. So I'm going to jump another friendly amount for me, which is 30. That gives me up to 70. And then another friendly amount to go from 70 to 74. That's going to be another 4. So it took me 4 plus 30 plus 4 to get from 36 to 74. So that's a total of 38. So the difference between 74 and 36 is 38. Again, many people do this when they're counting change. So if they know that they need to give back $36, or sorry, they need to give back, they were given, no, I'm confused now. I'm not even gonna go there because I'm just gonna confuse myself and confuse you. Anyway, this is a way that you can do subtraction by adding up, because that's something that might be more comfortable and familiar. All right, mind's on. Let's engage in some prior learning and see what tools we need for today. So we need a reminder of what the Pythagorean Theorem is, which hopefully you're familiar with. Hopefully it's you remember it from the past, which is c squared equals a squared plus b squared. But we're going to look and see what that means a little bit. We're not going to go into a lot of practice or depth with it, but just a little bit of understanding of conceptually what's going on. First, we need to acknowledge that mathematicians in Babylonia, in India, in China discovered this relationship first. We call it the Pythagorean Theorem here in Western culture, in Canada, in North America, but it isn't like the Pythagorean group and Pythagoras were not the people who started this first. There's proof that other folks all over the world were using this relationship in construction and all sorts of things before the Greeks were doing it. So that's just acknowledgement of that math has a really complex history, and often in Western culture, in Eurocentric culture, we focus on the white people who have made these more familiar to us. That's where our education is focused on, and that's just not accurate. There are other folks all over the world who are doing math and understanding these relationships well before only the white people were. So that's just a caveat there. Just stick that in there. Okay, but what are we talking about when we're still going to call it the Pythagorean theorem because that's what we're familiar with. But we're talking about this relationship. We're looking at a right angle triangle. And what the relationship is saying is that we label our sides the same as usual, our vertices A, B, and C. C, our hypotenuse side, our side across from our right angle, which is we always label our side C in this context. And then we're going to label our other sides A and B. So what this is saying is that if we were to square our side lengths, so we have A squared, which is our side length squared, and B squared, our side length B squared. So if we take those two the actual area squares, and add them together, we have the same as C, our side length C squared. They add up to the same area. So that's what the Pythagorean theorem is saying. We are not going to be able to prove it today, but we're just sort of looking at how that relationship is, and we're going to be using that with our cosine law. So it's important to remember that. So that C squared, the square of the hypotenuse length, is equal to A squared plus B squared, which is the square of the other two sides. I'm going to link some videos in our show notes that prove this. There's some great visual proofs that really just connect to what's actually going on, just to sort of really affirm what's conceptually going on. So you can check those out. There are other YouTube videos that you can check out. They're like a minute, maybe, or a minute and a half, maybe. They're really quick to just visually see what's going on. Okay, active learning. Let's explore this new concept of the cosine law. Wondering when we're going to use this in real life? Well, we are building patience and frustration tolerance yet again. That's part of what we're doing in our course. Getting comfortable with numbers, comfortable with weird situations, comfortable with things that are confusing, having to take time and work through things. That is skills that you're going to need every time, all over in your life. So that's part of what we're doing while we're doing math, but also part of what we're doing. So cosine is all around us. I have 3 different visuals on the video that are showing, they all end up actually are showing satellites. There are other ways that we use it, but these are the best videos that are visuals that I could find. So like triangulation in terms of cell towers, so how people can use GPS, satellites in terms of measuring distance between buildings and construction, also in terms of measuring the size of land masses, so lakes or rivers or hills, and creating maps, all of that, things that we figuring out distance, a lot of distance that is really hard for us to measure. We can't just take a measuring tape and lay it out. Using the cosine, using trigonometry helps us understand those distances. So first, we're going to look at the conceptual understanding of how the cosine law is derived, because I know that helps some folks to understand where it comes from. However, this is not in your IL booklet, and you do not have to know it. It is a little bit complicated. It's a little bit mind-bending, so it's okay if you don't understand it. If you are comfortable just using the formula and applying it to the situation, recognizing when you need to use it and plugging your numbers in, that is totally fine. If conceptually you want to understand where it's coming from and you want to spend some time, this little next section is for you. If you're watching the replay and you just want to skip over the conceptual understanding, you can just skip over it. I have all the chapters linked so that you can just pause the video and click onto the next chapter, either through the bar at the bottom of the video, or if you go back to the show notes, and then you can just click on the next part. So why does a cosine law make sense? So we have a triangle, any kind of triangle. It doesn't have to be a right angle triangle, any kind of triangle. And we're going to label our vertices A, B, and C, and our corresponding sides, small a, small b, small c. Then again, we're going to, like we did in the sine law, we're going to draw a perpendicular line from our vertice A down to our side A. And this, we're defining that as perpendicular. So we know that it's at a right angle because that's how we're drawing it. That's how we're defining it. So we have 2 triangles. We have a triangle A. We have 2 parts, a bigger one, a smaller one. It doesn't really matter. And what we're going to do is we're going to actually separate those 2 triangles and look at what's going on in those 2 triangles to then figure out how the cosine makes sense. So we now have triangle ABD and triangle ACD, because we split on that perpendicular line. We now have 2 right angle triangles. And our triangle ACD, I'm just going to define our side length to be x. We don't know how long it is. It doesn't really matter, but it's not in relationship to any of our other information. It's just, it's a side length, it's a distance, it's x. But that means that on our triangle ABD, our side length is a takeaway x, our new side length along the bottom, because it's no longer all of A. We've taken away this little x part. So now this side length is a takeaway x. So then we're going to look and we're going to use the Pythagorean theorem in triangle ABD, and we're going to figure out what relationship we have. So we have our c squared, right? Our hypotenuse, our c squared is equal to our one side, which is, we know is a minus x. So that's how we're defining that one side, squared, plus our other side, h squared. That's the definition of the Pythagorean theorem. So then if we expand using expanding our binomial, which is we did in unit 1. So c squared is equal to a squared minus 2ax plus x squared plus h. I've just expanded a minus x, all that squared, and that's giving me a squared minus 2ax plus x squared. Okay, so that's where we're at right now, and we're going to leave it for a minute. So we're going to go over to our other triangle, and we're going to use the Pythagorean theorem again on our triangle ACD, and we're going to see that b squared, our hypotenuse, is equal to x squared plus h squared. That's just the standard Pythagorean theorem, which I've just changed my variables according to what I've labeled on my triangle. So then we notice that if we can substitute that b squared is equal to x squared plus h squared, which is in our Pythagorean theorem from triangle ABD, and we can simplify that. We can say, okay, well, we have an x squared plus h squared, so we can replace that with just b squared, because that simplifies our statement. We have less going on. And we want from our original triangle where we had A, B, and C as our side lengths, and we don't have to use this h or this x in order to just have our triangles A, B, and C. So that's our first thing, is that we've substituted this in order to simplify and get our equation to be with just using A, B's, and C's instead of this x and this h, which we just sort of defined just to help us out to get there. So what we have is, now we have c squared equals a squared minus 2ax plus b squared. C is in triangle ABD, which is great, okay, and x is in triangle ACD. And really what we cared about was that original triangle that we had, which was ABC, and not these two little triangles. So how do we put all these pieces together so that we just have one triangle and we don't have these little parts? So the other thing that we need to know is that in triangle ACD, we can figure out what x is equal by saying cosine is equal to x over b, our adjacent over our hypotenuse. So x is equal to b times cosine c. Just rearranging it to figure what x is equal to. Okay, so going back to our original triangle with ABC as our vertices and our side lengths A, B, and C. This is just like we have a regular triangle, nothing fancy. And we know that c squared, from the work that we just did, we know that c squared is equal to a squared minus 2ax plus b squared. And we know that x is equal to b times cos c from what we did before. We're really just manipulating things to get us to what we want. So we have this x, we can replace x with b times cos c because we figured out that they were equal previously. So if I replace that, I get c squared equals a squared minus 2a then times b times cos c plus b squared. Then I'm just going to rearrange it so that it's a little bit organized differently. But I end up with c squared equals a squared plus b squared minus 2a times b times cos c. And now I have an equation that is just made up of my sides A, B, and C, and one of my angles. I'm going to have to know one of my angles. And that's what the sine law is. So we can go through the exact same process and cut our triangle with our height, with our perpendicular height at any of the vertices, and we would end up with the cosine law, with rearranging slightly different. So it doesn't matter which way, but our cosine law is c squared equals a squared plus b squared minus 2ab cos c. Or if you could rearrange it so that it's a squared equals b squared plus c squared minus 2bc cos a, or it could be b squared equals a squared plus c squared minus 2ac cos b. These are all exactly the same. They just rearrange the letters depending on what your reference angles are, what information you know, but it doesn't even really matter. You don't even really need to use all three of them. You can just use one and define your sides, just put them in, make sure that it's relating. So you really need to notice that c squared, the side that is on the side by itself, so that's c. And so your angle is angle C. So it's opposite the angle that you're using. And then your other two sides are the other two places. So you'll notice, so in the c squared, it's cos C. In the a squared, it's cos A. In the b squared, it's cos B. So you just really need to remember that. And that's all that really matters, opposed to knowing which formula is the right one to use, because they're all just the same, basically. All right, so that's confusing. Again, if conceptually you don't need to understand where the formula comes from, that is completely fine. You do not need to know it for the course. You are not going to reproduce it. You just need to be able to use the cosine law. But if it helps you to use the cosine law to understand where it came from, that's what the conceptual part is that we just did. If that doesn't help you, forget about that. And now we're just going to apply. We're going to figure out when to use the cosine law and how to do it. So we are recognizing when to use the cosine law. This is on page 27 of your IL book. So this is now actually in your booklet. So first, it can be any kind of triangle. It does not have to be a right angle triangle. This is why it's useful. There's lots of triangles in the world. There's more triangles in the world that are not right angle triangles and are right angle triangles. So we need situations where we can do things that when we don't have a right angle triangle. So what you need to know is either two side lengths and the angle, what's called contained, or is between those two sides. So looking at my diagram, we have a triangle QRS, and I know the side length that is R, or the side length that's between Q and S, and I know the side length is between R and S, so that's side length Q, and I know the angle at S. So that means that I can now figure out the unknown side, but that angle has to be between. If it isn't between, then we can't figure that out, but using the cosine law, you end up using the sine law. But in this case, the angle has to be between our two sides to be able to use the cosine law. The other situation is that if we know all three side lengths, so we have a triangle JKL, and I know my three side lengths, I have values for three side lengths, then I can solve for any of the unknown angles, because we can rearrange our formula such that we can find any of the unknown angles. That is one that we need. So cosine law we use if we either have two side lengths and an angle between those two side lengths, or we know all three sides, then we can figure out the angles. Otherwise, we would use the sine law or the primary trig, which we were doing before. Okay, so let's actually do some of this to figure out actually seeing what's going on. So to use the sine law to find a side, the cosine law to find a side, we have a triangle ABC. We have an angle at A, which is 36 degrees. And then we have a side length of 8 and a side length of 11 millimeters. And we're looking for the side length A, that's unknown. So we label our side B and C according to the regular way that we label our triangles, right? Little c is across from a C at the corner, little b is across from the big B that's at the corner. We have our angle, we see our angle is contained between those two sides that we know. So we can use the sine law, the cosine law, my bad. We can use the cosine law there. Because we're looking for A, we're going to use this form of the cosine law, but again, it doesn't matter. But so it's A squared is equal to B squared plus c squared minus 2bc times cos A, right? Our B and our C sides are the sides that we know, and our angle 36 is our angle A, and we're looking for our angle, our side A. So we're looking for our side A. We know our B, we know our side B, and we know our angle A. So we substitute those values in. That's all we do. And then we're just going to do the math. So we have a squared equals 8 squared plus 11 squared minus 2 times 8 times 11 times cos of 36. So then if we multiply those out, so we have a squared is equal to 64 plus 121 minus 176 times 0.8090. I just multiplied my whole values to get 176, and I did my cosine, and I wrote down just 4 decimal points. Remember, we have to do at least 4 decimal points. Then if we combine all those, we get a squared is equal to 42.6130. And then we need to take the square root of both those sides, right, to figure out what just a is. Right now we know what a squared is. We want to figure out what a squared a is. So a squared, the square root of a squared is equal to the square root of 42.6130. A little caveat to remember is that a squared, the square root of a squared is going to equal plus or minus a, right? We could have negative a times negative a is going to give us positive a squared, and positive a times positive a is going to give us positive times a squared. But because we're talking about distance, we ignore the negative because we don't have negative distance. That doesn't make sense. And we just talk about the positive. But sometimes that's something that comes up in a question, is that you get 2 answers because you have a negative and a positive, and you need to remember that we're just talking about the positive because we're talking about distance. So we end up with a is equal to 6.5 millimeters, because that's the square root of 42.6130. So it's figuring out which one to use, and then it's just plugging your values in and doing your calculations. All right, so now we're going to rearrange the cosine law. This is on page 29 of your IL booklet, to figure out how to find angles. Again, you don't have to memorize how to do this. It's okay if you don't, but it's just to figure out how this in your booklet and how to figure out when you're solving for angles, because sometimes we solve for angles. So we're going to start with c squared equals a squared plus b squared minus 2ab cos c. And we're trying to figure out how to solve for our angles. We're trying to isolate for cos c to figure out our angle. So we're going to add 2ab cos c to both sides, so that we ended up on one side where it's positive. And then that cancels off on the right. And then we're going to subtract c squared from both sides in order to cancel it off from the left. So we have 2ab cos c plus c squared minus c squared equals a squared plus b squared minus c squared. Then we're going to divide both sides by 2ab, because we had 2ab cos c equals a squared plus b squared minus c squared. We want to divide both sides by 2ab so that we get cos c by itself. And we end up with cos c equals a squared plus b squared minus c squared all over 2ab. Again, you do not need to be able to derive this. You don't need to do these steps. But doing these steps now means that we get a formula which we can use instead of having to input our numbers in and then do all the algebra afterwards. So the same way as before, we could do the exact same steps and rearrange and find cos A, or rearrange and find cos B, but something very similar. So cos A is equal to b squared plus c squared minus a squared all over 2bc. And cos B is equal to a squared plus c squared minus b squared all over 2ac. This feels like a lot of random alphabet soup a little bit when you're just saying it, but looking at it, you can see that these are the same. Your letters are in slightly different places depending on which angles and which sides that you have. So hopefully spending some time doing questions means that it doesn't seem quite so much like random alphabet numbers and letters that make no sense. Okay, so we're going to use the cosine law to find an angle. I typo here, I say to find a side. We're not going to find a side, we're going to find an angle. My bad. So using the cosine law to find angle, we can see that we have a triangle A, B, and C, and we know our three sides. We know that side A is 48 meters. We know that side B is 62 meters, and we know that side C is 51 meters. Oh, another thing to note in these diagrams is that they most likely are not going to be exactly precise. Your angles might be slightly off, your distances, your lengths might be slightly off. That's okay. We just follow what's labeled, how they're labeled, which can be frustrating in terms of you're trying to make it make sense. But that's just because sometimes it's hard to, in terms of saving time, we don't do it exact. That's the honest answer, the honest reason. Okay, so we're looking for angle B. That's what the question is indicating. So we're going to say that cos B is equal to A squared plus C squared, the two other sides, minus B squared, so the side opposite the angle we're looking for, all divided by 2AC, so 2 times the two sides that is not opposite the angle we're looking for, multiplied together. Again, being able to see it is going to make so much more sense than just listening. So we have our B, we see, our cos B is what we're looking for, our side B is what we have, and then we have our A's and our C's you can figure out where they're coming from. So we're just going to input our numbers. So we end up with cos B is equal to 48 squared plus 51 squared minus 62 squared, all divided by 2 times 48 times 51. So cos B is equal to 2,304 plus 2,601 minus 3,844, all divided by 4,896. You don't have to write them down. You can, or you can just do them in your calculator. So then cos B is equal to 0.2167. And then to find angle B, we need to do cos inverse of cos B is equal to cos inverse of 0.2167, which means that angle B is equal to 77.5 degrees. Remember, calculator has to be in degrees. For all of our trig, calculator has to be in degrees. All of our course, calculator is in degrees. That makes your life easy. Don't change it. Okay, so then we found a side, we found an angle, but how do we know which formula do we use? So you can use either formula anytime the sine law is required. You don't have to memorize them both. You can just use one of them. However, if you do that, you're going to end up having to do more algebra sometimes, and that might trip you up. So using the different ones depending on the situation might make your life easier instead of having to do more algebra and get that being messy. So if you want to do less algebra, which I would encourage, when you're solving for sides, use c squared equals a squared plus b squared minus 2ab times cos c. Because we have a side, c squared is our side, we're solving for a side, this is going to be the easier way to solve for a side. When we're solving for angles, use cos c equals a squared plus b squared minus c squared all over 2ab. Because we're solving for an angle, we have cos c, we have our angle isolated for, and therefore it's easier, we don't have to do as much algebra. All right, so if you'd like to pause the video and try some support questions on page 30 and do questions 1 through 9, you are welcome to do that. We're going to continue on and recap a little bit and then dive into a little bit of practice. So let's consolidate what we've learned so far today. So for lesson 13, the cosine law, we use the cosine law when we know 2 sides and the contained angle, or when we know all 3 sides. Those are the 2 situations why I would use the cosine law. Which formula do we use? Both versions work in all situations, but if we're looking for sides, we use c squared equals a squared plus b squared minus 2ab times cos c. I just write it out once for the sake of space, but again, depending on what you're finding side A or side B, you would use that slightly differently. And if you're finding angles, we do cos c is equal to a squared plus b squared minus c squared divided by 2ab. Again, you put in the right variables depending on your situation. As always, your calculator must be in degrees. It's going to happen to you. It's going to be in radians and gradians, and then you're going to be like, why does this make no sense? So that's why I'm continuing to say the same thing over again. It's got to be in degrees. All right, so our success criteria. Hopefully you can say, I can explain when to use the cosine law. And then hopefully you can say that you can solve for unknown sides and angles using the cosine law. You probably need some practice first. All right, let's do some practice together. So in triangle DEF, solve for F given that angle F is equal to 52 degrees, that side D is equal to 26.2 centimeters, and side E is equal to 18.8 centimeters. We're not given a diagram, so we're gonna have to draw what we have. Again, it does not need to be perfect. My triangle is not gonna be perfect, but I'm gonna label it so that we understand what's going on. I'm drawing a triangle. It's not a right angle triangle. It's got 3 sides, 3 angles. We're good to go. I'm going to label it D, E, F. It's fine if you don't label it exactly the same, as long as your corresponding, what you say is F is the same angle, what you say is D is the same. Doesn't matter where it looks, the orientation. So we are solving for side F. So I'm going to label F, side F, given that angle F is 52 degrees. So I'm going to go and label that my angle F is 52 degrees. My side D is 26.2 centimeters, and my side E is 18.8 centimeters. So now that I've visualized, I've drawn what is going on in the question, I can see I have an angle that's contained by 2 sides. Because that angle is between my 2 sides, I can use the cosine to find my other side. Great. Now these are none of the letters that we've used before, but I'm just going to substitute my letters in because I remember the cosine law. If you wanted to write out c squared equals a squared plus b squared minus 2ab times cos c, you could, or you can just write the letters that you have. So f squared, because I'm looking for f, is equal to d squared plus e squared, my other 2 sides, minus 2 times d times e times my other 2 sides times cos of my angle that is opposite my side that I'm looking for. It doesn't matter if you write d squared plus e squared or if you write e squared plus d squared. If you're adding 2 plus 3 and you're adding 3 plus 2, they're the same thing. Okay. So now I'm going to substitute in the amounts the values that I have. So f squared is what I'm looking for. Then I have d squared is going to be 26.2. Sorry, I wrote that badly. It looks like I'm squaring, and that's not what I meant to be doing. Matters if your numbers are big or little. If you want to, you can put it in brackets if that just helps keep yourself organized. Plus 18.8 squared minus 2 times 26.2 times 18.8 times cos of 52. Okay, so then f squared equals, and I am going to go to Desmos and put it all in Desmos. I'm not going to write it all out to save time, but I'm going to put it all in and go from there. So we have 26.2 squared plus 18.8 squared minus 2 times 26.2 times 18.8 times cos of 52. So that's all in the same way that I have it written down, equals 433.379. So 433.38. So f squared equals 433.38. Is that correct? Yes. Okay, so then now my next step is I'm going to take the square root of f squared, and I'm taking the square root of 433.38. And so f is equal to, go back to my Desmos. Desmos is a little bit annoying because you can't just press the square root after you've done your thing. I have to put square root 433.38. You could do more decimal places if you wanted to. So f equals 20.817, so 20.8, because we only need 1 decimal place, centimeters. So then we found the length of f. Again, It's not exactly how, it's not correct in terms of how I drew it, but that's okay. The math is correct. The drawing is just a visualization. All right, let's keep going so we get some more in. All right, number 2, in triangle HJK, solve for angle J, given H equals 9 centimeters, J equals 7 centimeters, and K equals 8 centimeters. So I have a triangle labeled HJK. I'm solving for angle J. That's what I'm looking for. And I know that H is 9 centimeters and side J is 7 and side K is 8 centimeters. So I know 3 sides and I'm looking for an angle, so I can use the cosine law. So I'm going to do cos of J is equal to K squared plus H squared minus J squared. So the 2 other sides minus the side opposite the angle divided by 2 KH minus divided by 2 times the 2 sides that are not opposite my angle. That's how I memorize it. But you'll be able to look it up. You'll be able to, I'll give it to you on a formula sheet for your exam, and you can totally look it up at this point. You don't have to memorize it. So K cos of J is equal to 8 squared plus 9 squared minus 7 squared, all divided by 2 times 8 times 9. Again, we're going to put it in Desmos. So we have 8 squared plus 9 squared minus 7 squared. Now I want it all to be divided by 2 times 8 times 9. So I just highlighted all of it to make sure that the whole thing was going to be divided. I could have also put the top in brackets. Work too, but you just have to pay attention in terms of what's being divided when you're doing it on your calculator. So that gives me 0.00000, sorry, 0.666666. So cos of J is equal to 0.6667. So then to find J, we do cos inverse of cos J and then cos inverse of 0.6667. So then angle J is equal to, go back to Desmos. So remember, we have to go to second function to get cos inverse of 0.6667, 4 decimal places, is equal to 48 degrees. That's how we find an angle using cosine law. All right, word problem. A radar station is tracking 2 ships as shown below. How far apart are the 2 ships to the nearest 1/10 of a kilometer? So we have a triangle with a radar station and a big cruise liner and a small sailboat. And we know that it's 70 degrees between the 2 from the radar station. The distance to the cruiser is 4.9 kilometers. The distance to the sailboat is 8.6 kilometers. How far are they between the 2 of them? Do we need to be worried about them crashing? That's what radar stations do. So I'm going to label my sides, and I'm just going to label them. Doesn't matter if they're in order or not. I'm going to label the radar station R, the sailboat S, and the cruise liner C. So then I can label my little sides, my sides opposite with my corresponding little letters. So I'm looking for side R, that's the distance between the 2. So R squared is equal to S squared plus C squared minus 2SC times cos of capital R. And then I substitute in what I know. So S squared is 4.9 squared plus C squared is 6.8 squared minus 2 times 4.9 times 6.8 times cos of 70. That's my angle R. So R squared, again, I'm going to use my calculator. We have 4.9 squared plus 6.8 squared minus 2 times 4.9 times 6.8 times cos of 70 equals 47.4578. 47.4578. So then to find the square root of r squared, to figure out what r is, we do the square root of 47.4578. Again, didn't use our calculator. So the square root of 47, see, I just clicked radians by accident. 47.4578 is equal to 6.88, so 6.9. So R is equal to 6.9 kilometers. So the ships 6.9 kilometers apart. And that's how we can figure out a word problem. We've answered the question. All right, question 4. A soccer player takes a shot on a standard net that is 7.3 meters wide. If the player is 10 meters from one goalpost and 14 meters from the other, through what angle can a goal be made? So this might be hard to visualize. So let's draw ourselves a picture. Always, if we don't have a picture given to us, let's draw it so that we can figure out what's going on. So a soccer player, so we have a person, my beautiful stick people, takes a shot on a standard net that, so we have a standard net. So I'm drawing a beautiful net that is 7.3 meters wide. If the player is 10 meters from one goalpost and 10 meters from, or sorry, 14 meters from the other goalpost, then what angle can they shoot through in order to make this? So now that we've drawn it, we have a triangle. We can see that we have a triangle that has side lengths 10 meters, 7.3 meters, and 14 meters. And we're looking for the angle that we can shoot in order to make a score goal. Because we have 3 side lengths and are looking for an angle, we can use our cosine law. We are going to label our sides. This time I'm going to, and our angles, I'm just going to label them A, B, C for the sake of ease. It doesn't matter. A, that I'm going to label my sides, little a is across from my vertex A, little b is across from my vertex B, and little c is across from my vertex C. So then I'm looking for angle A. So I'm going to say cos of A is equal to B squared plus C squared, my 2 other sides, minus A squared, this side across from the angle that I'm looking for, divided by 2BC, 2 times the 2 sides that are not opposite of the angle that I'm looking for. So now cos of A, we substitute in our values. So we have B is 14 squared plus 10 squared minus 7.3 squared, all divided by 2 times 14 times 10. So cos of A, we're going to put that into Desmos or our calculator. So we have 14 squared plus 10 squared minus 7.3 squared. See, this time I just click divide and it only is dividing that last one on my Desmos calculator, and that's not what I meant. So I need to go back. I need to delete that. I need to highlight all of those. I can either go from the and put them in brackets and then press divide, and then it goes underneath it, or I can just highlight it and then press divide and it'll go underneath them all. But you can make sure that you're doing it. If you're not doing it on Desmos and you don't see it like that, you have to make sure that on your calculator, you are putting the brackets in to make sure that it's doing the order of operation that you want. All right, so then that all equals, when I put it in properly, I get cos A is equal to 0.8668. 0.8668. So to find my angle A, cos of inverse of cos A equals cos inverse of 0.8668. So back on my calculator, finding cos inverse of 0.8668 is equal to 29.9. So we're going to say angle A is 30 degrees. So the goal can be made if the shot is taken within an angle of 30 degrees. And there you go. Have we answered the question? Through what angle can the goal be made? That's what the answer that we've answered. We've done that. Perfect. All right, and that's the cosine law. So all of these that we've done are very similar. The hard part is figuring out which one to use and when, and to make sure that you have the correct formula and that you have all the correct parts. Then you're substituting in what you know and what you're trying to find. And then you are using your calculator, making sure you do that correctly. On our next lesson, we're going to do more word problems and figuring out which situation are you going to use cosine law in, which one you're going to be using the sine law, when you're going to use primary trig. We're going to practice that. That's on our next lesson. So we'll have lots of practice with that because that's really the part that is a little bit more tricky. Otherwise, you're just plugging numbers in and making sure your calculator doesn't screw you up. As always, if you have any questions, please contact me. This stuff can be confusing. That's completely understandable. So please contact me so we can go over things if you need it. My number to call and leave a message and let me know when would be a good time to call you back is 807-737-1488, or toll free, it's 1-800-667-3703. My email address comes directly to me, so that's bronwyn.slate, which is spelled BRONWYN.SLATE@nnec.on.ca. Or you can connect with me through Facebook. I'm pretty quick to get back at bslate Wahsa. You can watch this replay on YouTube where you can slow things down, pause it if you need to, go back. It's really good to work through it at your own pace. It does not, I have to go through it quickly because I have a chunk of time, but having it on YouTube means that you really can go at your own pace. So please do that if you need to. I hope you have a lovely day. Thanks so much for joining me. Miigwech.